Okay, part A of this question, question number 5, and we are given that 2 ln x plus 1 plus ln x equal to ln x plus 9, and then we have to show that x equal to square root of 9 over x plus 2. Very good, so let's begin by saying that we have ln x plus 1 all squared. Alright, then you plus ln x and should get ln x plus 9. So using the properties or the laws of logarithms, this is what we come up with now. Okay, you multiply these two, and then from here you cancel the logarithmic sign, so we got x into x plus 1 to the square is equal to x plus 9. You can expand this, x into x squared plus 2x plus 1 is equal to x plus 9. So x cubed plus 2x squared plus x, the x come here, the 9 can come on this side, and then it's equal to 0. So we have x cubed plus 2x, that should have been then 2x squared. So 2x squared, this cancels out, minus 9 is equal to 0. So we can factor x squared outside, and inside we got x plus 2. The 9 can go back on the left and on the right hand side, so x squared is equal to 9 over x plus 2. In other words, x is equal to the square root of everything on the right hand side. So here we are for the first part. For the second part B, for this, there exists a single root. Now we need to show that there exists this root between 1.5 and 2.0 by calculation. So how are we going to do this? So let's try and see how we can pull through this. Now, because we've got these two, we've got to use a formula based on part 1. So what we're going to do is let fx is equal to, say, x minus root of 9 over x plus 2. And then what we're going to do is we're going to try f 1.5, which all comes down to 1.5 minus square root of 9 over 1.5 plus 2. That's going to give us minus 0.1 something. If you try for f 2.0, you're going to come down to 2.0 minus the square root of 9 over 2.0 plus 2. And if you were to check this out in your calculator, here we are. So the product of f 1.5 times f 2.0 produces a negative value. And this indicates the presence of a root between these intervals. It's always the case. So here we are for the second. Okay, for part C of the question, we need to use an iterative formula based in part B to find correct to 3 significant figures, this root, and give the result of each iteration correct to 5 significant figures. Now, first of all, I want to find the initial value of x, which is then x is equal to 1.5 plus 2.0 divided by 2 comes to 1.75. So f 1.75 basically is all of that, so divided by, this was a square root of something, square root of, alright, so that's going to be 1.75 plus 2. So let's do that on a calculator. Square root of 9 over 1.75 plus 2. And, alright, so there we go. So this is 1.5491. So let's say 1.549. So it's 5 significant figures, so 92. Right, so the next thing you do, you go back to the formula, and then where you've got the initial value of x, just put the answer there. the second value would be 1.5924. So what we have, square root of all of that, which then comes to 1.5924. And then again, so this calculator is going to give us 1.5828. You can go on and try and check from your calculator. 1.5849. And then again, comes to 1.5844. The next one is 1.5845. I would say 46. 1.5845. 1.5845 again. It goes on forever. 45, and at least we're coming with 45 again. So, and again, you're going to get the same result, 1.5845. So the root then can be said to be, sorry about that, should have pushed this up. Anyway, the root alpha is 1.5823 significant figures. Anyway, I'm sure you were able to get what I mean when I was doing the calculation. Take care.